Lesson 12.2 is all about combinations and permutations. And we'll get to combinations later, but right now we're going to talk about permutations, which are an arrangement of any number of items in a definite order. The fact that order matters is very important here. So a real-life example of permutations would be bike locks, where let's say I have a bike lock that's combination, or should I say permutation, is 1, 2, 3, 4. And you try to break into it by using the same numbers, but in a different order. So say 4, 1, 2, 3. So even though these are the exact same numbers, 1 and 1, 2 and 2, 3 and 3, 4 and 4, because this permutation on bottom is not in the same exact order, it would not work to open up that lock. So bike locks should actually be called permutation locks instead of combination locks, because in them the order does matter. So let's look at another example of how permutations work. So our example says 8 people enter the best pie contest. How many ways can red, or blue, red, and green ribbons be awarded? So this is going to look really similar to our fundamental counting principle problem from before when we were looking at scheduling classes, where if we look at the first place prize, or our blue ribbon, we would say that there are 8 people who can win that. Now if we look at our second prize, or the red ribbon, if one person already won the first place prize, now only 7 people can win this one. And if one person took the blue ribbon, one person took the red ribbon, then there are only 6 people left who can get the green one. So 8 times 7 times 6. Another way to write this in permutation notation would be this NPR, where N is the total possible items and R is how many we will pick up. So we would say 8P, P stands for permutations, 3. Now what this means is N factorial, so whatever number was in this spot here, factorial, over the amount N minus R factorial again. Now factorial basically just means multiply that number by all of the other whole numbers beneath it. So we would say that in this case we would have 8 factorial over, we would say 8 minus 3 factorial, which we can simplify to 8 factorial over 8 minus 3 is 5 factorial. Now if we wanted to see how this would actually spell out, we'd have 8 times 7 times 6, 5, 4, 3, 2 times 1, all over 5 times 4 times 3 times 2 times 1. Now if you'll notice though, 5, 4, 3, 2, and 1 happen in both cases. So since it's all multiply and it's being divided, we can factor out or cancel out the 5, 4, 3, 2, and 1, leaving us with just the 8 times 7 times 6, which is the same as what we got in our fundamental counting principle. So in the end, we would say that 8P3 would come out to this 8 times 7 times 6, which is going to be 312. So there are 312 possible ways that we can award a blue, red, or a green ribbon. Now, sometimes we will have these permutations, not combinations, we'll have the permutations with repetition. Like in this case, where we're looking at the word banana, and we want to rearrange those letters in a unique way. But, if you'll notice, A happens 3 times, and N happens 2 times. So in this case, we would say that there are 6 letters in total. So 6 is going to be our N. So N is our total letters, and that equals 6. P is just one of our repeated letters, or any repeated event that we're looking for. So we would say in this case it would be our N which happens twice. Q is our other repeated, in which case we say is A, oops, and this happens 3 times. So in this case, we would say that we are looking at 6 factorial over, we have 2 factorial and 3 factorial for our P and our Q. So if we were to spell this one out, 6 times 5, 4, 3, 2, 1 over 2 times 1 is 2 factorial times 3 times 2 times 1 is 3 factorial. Again, here we can see 3, 2, and 1, 3, 2, and 1. The 1 will never affect either side, the numerator or denominator, because multiplying by 1 doesn't change anything. But we can say 2 goes into 4 twice. So we factored out a 2 from there. So now we're just left with 6 times 5 times 2, which in the end is just going to be 60. So there are 60 possible ways to rearrange the letters in the word banana that will each be unique.